Okay, we're ready to kick off our fourth Quant conference, and let's not waste any time. People are strolling into the quote-unquote room. I'm Patrick Zorro. I'll be monitoring everything, and Varun, who is joining us from India, actually, we've done some work with Varun and the quantitative on several occasions, and he's going to be talking to us about algo trading and machine learning. Varun, go ahead.
Yes, thank you, Professor Zara. So welcome everyone. This is Varun Kumar. So I'm working as quantitative analyst in Quant. So Quant is Asia's pioneer in training for quantitative and algorithmic trading. So I have close to 8 years experience in this industry. So I worked as a trader, global micro analyst, algo trading strategist, and currently working as a quantitative analyst. So today the topic is algo trading and machine learning. So agenda. So we are going to discuss or have a brief overview of algo trading system, and also we are going to discuss the need for algo trading, and then we'll see why or how machine learning is used with algo trading, and we'll also discuss several approaches of machine learning for algo trading, and we'll end the session by discussing about the limitations of machine learning for algo trading. So let's start. Let's start with algo trading. So what is algo trading? So algo trading, by definition, it is executing orders using automated pre-programmed trading instructions. So as a manual trader, you will do your own analysis and then you will do everything manually. But in algo trading, you will automate all those processes, not just the research, but also the trades, etc. So with those pre-programmed trading instructions, algorithm will go ahead and place the trades. So this is about the definition, but let's just see the main components of algo trading system. So the first important component of an algo trading system is data. So there are several types of data you can pump into your algo trading system. So especially the first or important data is price. So this is pretty common. So whatever algo trading system you design, either to research or to trade, so the first data point you give is price. And following that, you can also give fundamental data. So fundamental data is basically related to companies' income sheets, balance sheets, etc., which gives the fundamental idea of the company. So even this data can be used as input for your algo trading system, and it's not common to use economic data. So generally macroeconomic data such as income reports or interest rates or non-farm payrolls, etc. So you can also use this data. And also news, like in past 5 years, we'll see lots of algo trading systems that are trading based on news. Basically, the system will read the news, understand, score the sentiment, and take trading decisions accordingly. And also social media. So you must have already seen lots of accounts in Twitter that are actually impacting the market, not just Twitter. Even in Reddit, there are many Reddit groups that discusses about a particular stock and have impact when the market opens. So you can also scan all these things using your algorithm and use them as an input data for your system. And you can do this by taking advantage of data APIs. So this is the first and foremost important part of data, or part of algo trading system, which is data. So the next part is model strategy. So once you are ready with your data, you need to define your strategy, or you define your model with which your algo trading system will run. So basically, when we say strategy, it is basically a trading hypothesis. So what is the logic with which you want to trade? It can be as simple as buy Apple every September, or buy particular commodity every Wednesday, or it can be as complicated as studying all the news related to Apple for the past 10 years, making the sentiment analysis, and then taking a trade. So it can be in this range of complexity, but then by definition, it's just a hypothesis you define. And with this hypothesis, you define certain trading rules. So following these trading rules, the algorithm is going to make trades. So in general, there are lots of people, or a huge chunk of traders use technical analysis, where there are certain indicators or certain ways to analyze the price using technical analysis concepts. So you can also code this strategies or code this approach and create your algo trading system. In fact, create your model strategy. Or you can also use statistical analysis if you want. You can use econometric models as well, statistic-based economic models, or like ARIMA model, ARMA model, SARIMA model, etc. And if you have a statistical model which you believe that it can generate money or it can predict the stock, you can also use them to create your strategy. And you can also use mathematical models. So there are many mathematical models that defines the regime of a market. For example, Markov chain models, etc. So you can also use them. So all these things are different ways to model your strategy. And once you model your strategy, the next step is backtesting. So backtesting is a place where you understand the historical performance of this model. So basically you run this model with these trading groups in the historical data and understand how this stock or how this strategy would have performed. And once you're happy with these results, you will go to the next step, which is execution. So execution generally has, like, basically there are two types of execution. Either you can go for manual execution, where you use your algo trading system to give you signals, probably through an API or through a website or even through mobile apps, like you to buy a stock or sell a stock. Then you will take manual trades, you will manually place orders. Or you can also automate this step as well, which is an automatic execution where you will use trade APIs. So all brokers provide you trade APIs. You can plug your trade APIs to your algo trading system, and once the signal was generated by your model, you can let them take the trades. And last but not least, this is also an important part of any algo trading system, which is risk management. So this is a place where you allocate capital, or you decide what part of capital you want to give to what algorithm or what stock. And also you design certain risk parameters like stop loss, take profit, how much risk you want to take, or what are your expectations from a particular trade. So combining all this, so these are the 5 important parts of an algo trading system. It can be more complicated than this or more nuanced than this, but this is on a high level. This is how a typical algo trading system looks like. So now, why do we need algo trading? So what is the need, or what gave rise to algo trading? So first of all, with algo trading, you can monitor multiple assets and you can also trade multiple markets at a time. So as a manual trader, you are limited. So with your algorithmic trading, you can trade in global markets or simultaneously at a time. You can at a time trade in European markets or cryptocurrency markets, Asian markets at a time. And also a stock can monitor multiple assets. Let's say you have a trading strategy which is profitable, but as a manual trader, you are limited. You can't just scan all 100 or 200 stocks at once and take trade. But algorithm can probably scan all 1,000 stocks of a particular exchange across globe and then take trading decisions. And also the market, basically markets are moved by certain events or certain release of macroeconomic reports. So as a manual trader, there is a lag. So for you to study the report and then take a decision. But as an algo, it has no lag. So it has much faster response. And a main drawback of manual trading is emotional trading. Basically, you'll get emotional when you are making losses or when your stock is not moving as expected, etc. But these algos are not susceptible to emotional trading. So there is no place for emotional trading. And reduction of error. So as a manual trader, there may be many ways an error could creep in. It could be a fat finger error, or it could be probably a distraction you might have, which might have caused an error. But as an algo, there are a gradual decrease of errors. And also there is very low maintenance for algo. So once everything is set up and all the tests are done, and once it is giving you good performance or there are no issues with it, so the maintenance will be low. And algos basically gives you better execution price. Let's say you studied a stock and you wanted to buy it $100. By the time you place the order, basically the price might have already moved away from the entry price you want to take a position. So, and also optimal execution is very difficult for a manual trader. So as an algorithm, it is easy for it to do, place a trade at a best price.
Varun, go ahead.
Yes.
Finish your slide.
Yes. And the last part is strategy backtest. So with an algorithm, you can actually backtest a strategy across different exchanges and across multiple assets at a time, and quickly get the results and then take a decision whether to deploy the strategy or not. Yes, I'm done with this slide.
Yeah. Okay. So, I mean, that sounds great. The only thing is, so we still need, somebody needs to, I could see the implication of the ease and the reduction and the low maintenance and all that, but then in terms of building the algorithm itself, you still need people to do that.
Yes.
So, I mean, this is just all positive. I mean,
no, it's not all positive. So I'm going to cover that.
Okay.
Also. As we move forward, I'm actually planning to talk about them also. So there are certain challenges, as you were saying. So we're going to discuss about that. And yes. So basically, to summarize, so what is the need for algo trading in a single line? We can say that the need is to overcome our limitations and increase efficiency of whatever processes we have or strategies. So, but there are certain challenges. So first of all, there are certain skills you need to have to create an algorithm or to have an algo trading system. First of all, programming. So you need to be good at programming, especially it depends on the market you're trading or the frequency with which you want to trade. For example, if you want to be a high frequency trader, you should generally people code in C++. So you need to be very good at programming. When we say good, it should be very, very good. So basic level knowledge in programming will not cut it to create an algo trading system. So this is one of the main challenges. And also data management. So basically, if it is an intraday trading algorithm, there is a huge amount of data you need to manage, and every second or in a less than a second, you get huge amount of data. So you need to have particular infrastructure and also skills to manage this data. And also algorithms, once you create an algorithm, it doesn't mean that it's going to be profitable like lifelong. So most of the algorithms lose its particular alpha or money making capability within a very short time. So there is a need for basically quality control or revamp of algorithms at particular intervals of time. So even that is a skill that a particular person might have. So to create an algo trading system. So now,
which I'm sorry, Varun,
yeah,
which you went a little quick on the programming and the which
yeah.
language is best used for algo trading?
Used, yes. So basically, I do use Python, and depends on the use case also. For example, I'll tell you how different programming languages are used. So like not recently, but R used to be pretty famous, especially for research. While creating the algorithm or researching particular strategies, so people used to use a statistical programming language called R. And then when they are deploying, so if the speed is important for you, and if your system should have low latency, so then people prefer C++, but latency is not an issue for you. And if you're not doing high frequency trading, and if you're doing low frequency or medium frequency trading, you can code with Python. And Python is most preferred because there are lots of packages that are already available that are going to help you to design your algo trading system right from getting the data until backtesting also. So there are several famous packages. Even for technical analysis, there is a package called TLM. If you want to backtest, there is a package called Backtester. And if you want to get data, you can actually get it from Yahoo Finance for free by using a package called Y Finance. So there are several ways the Python programming has evolved because of the ongoing needs for algo trading community. Yeah. So can you move forward, Mr. Gaurav?
Yeah, please. Don't wait for me. Go ahead.
So now that we understood a basic structure of algo trading system, let's see how machine learning is used for algo trading. So basically, the first and foremost thing, machine learning is a subset of artificial intelligence. When I say subset, so this is how these are divided. So machine learning is a part of artificial intelligence, whereas deep learning is a part of machine learning. So when we say artificial intelligence, it deals with machine intelligence part of thing. It deals at a higher level and coding for particular hardware as well. But when we talk about machine learning, it especially focuses on creating algorithms that take decisions without explicitly programming for a particular logic. So we are going to discuss more about it as we move forward. And when we say deep learning, it is a part of machine learning, but it's a bit different from the fundamental approach of it, where you don't have any particular model, but then you use certain aspects like neural networks, etc. So to train a model and then tune it as we move forward. So we're going to discuss a bit about this also. So let's just
Varun, hold on. I have
Yes.
one question. Somebody's asking, what courses for undergraduate student do you suggest to take for first-year students if they are seeking a career in algo trading? What kind of courses would you recommend?
I would recommend, first of all, you should be good at statistics. So that's the most fundamental thing. And then whichever course which gives you knowledge on economics or financial aspects would be really, really helpful. And of course, programming. So a basic programming language would open lots of doors for you to improve your knowledge by consuming online material, etc. So if you have a chance to enroll to courses in your college, so you better focus on statistics, programming, and also economics or finance related courses.
Great, thank you.
Yes. So as we discussed, machine learning is a subset of AI. And ideally, what happens is it learns from data. So the whole idea of creating a machine learning system is to make it learn from the data you give. And then using the data, so the system or a machine learning algorithm will make predictions and also take some certain decisions. So far we have understood the structure of algo trading system. Let's just see how a structure of machine learning based algo trading system is. So just like a normal algo trading system, even machine learning based algo trading system has a data module, where certainly the data can be as simple as giving OHLC data. OHLC basically for the uninitiated, open, high, low close, basically every day's open, high, low close, or every minute's open, high, low close. You can give certain data like this, or you can also give the same data you give for your algorithm system, like fundamental data, economic data, news, social media, etc. So this is the first step. And once you're ready, this is called raw data. Basically, you don't change any data. This is a raw data. From this data, you make certain changes. So the next step is pre-processing. So pre-processing is a step where you kind of clean the data. So for example, you would remove unwanted observation. Basically, when you get a data, there may be some duplicate data rows, or that there may be some corrupted data files, etc. So first step is to remove unwanted observations or unwanted data. And next, you need to fix the structural errors. You need to study the data and understand if there are any structural errors. For example, in this data I'm showing, so as you can see, this is a daily frequency data. So for per day, there are 4 data points. Suddenly, let's say it suddenly turned into a weekly data. So there is a structural mistake. So you need to understand how the structure of the data is, and then if there is a problem, you need to fix it. So all this comes under pre-processing step. And the next one is managing unwanted outliers. Sometimes, see, that the quality of data depends on your data provider, and error can come at any point. So you need to understand your data, understand the distributions of your data, and if there are any unwanted outliers. For example, let's say this is an Apple stock. For example, I'm just giving an example. Let's say it is an Apple stock, and you can see all the prices are around 120. Suddenly, you see a price of 5,000. So that is an outlier. So you need to see if there are any outliers in your data, and if they are, you need to take a decision whether to remove them or then inquire why the outlier is. And then the last one is handling missing data. So this is also very important, and this is a common problem a data module of ML faces. So there could be a missing data. A missing data could be something like, for example, out of 122.33, there could be NaN value here. So then you need to decide what you want to do. Do you want to delete the particular row, or do you want to replace it with something else? So these kind of decisions should be taken. And I hope my screen is visible. Yes. So the next step is feature engineering. So this is the most important part of a ML architecture. So when we say features are basically, these are called predictors. So these are the elements with which you try to predict a particular stock price or create a particular model. So this is called feature engineering. Basically, there are 4 steps in feature engineering. So first one is converting, basically ideally what is feature engineering? It is converting raw data into features or attributes. So now that you have raw data, for example, we had open, high, low, close data. Using this data, you create certain features that's going to give you information about the data and then help you to create certain models. So the first step is feature creation. So feature creation, let's say it comes from the problem statement. For example, if I want to predict Apple price of tomorrow, so I'm going to create certain features or decide certain features that's going to help me. If you think about it, historical data, certain open, high, low, close can help me, or news data of Apple can help me, or fundamental data or economic reports of Apple data can help me. So these are all part of feature creation. Basically, we are understanding the problem statement and listing down the features. So next part is feature transformations. So this is an interesting step. So for example, consider a case where you are taking open, high, low, close data of Apple and also volume data of Apple. So if you think the price, top price would be around probably, let's say $100, but then volume would be in a matter of millions. So if you are giving that data into an algorithm, there is a mismatch because the volume data is in millions, but then price data is in hundreds or thousands. So that volume data might influence your model.
Varun?